These are the frequently asked questions for pre-calculus, and this is section P7. Number 16 has solved the inequality, use algebra to solve the corresponding equation. So for number 16, the first thing I noticed was we do have a common monomial factor in all three of those terms, and that's an x. So if we pull that out, we're left with x squared minus x minus 30 is less than or equal to 0. Now it's important that that 0 is on one side so we can find the cutoffs, find out where those zeros are at. So now I'm going to try and factor that. And I notice that negative 30, that's not a perfect square. So I need two numbers that multiply to negative 30 and add to negative 1, and that of course is negative 6 and positive 5. So what I see is that I have a 0 at 0, a 0 at 6, and a 0 at negative 5. And like I said before, this is not a quadratic. So in order for us to figure out what's going on with this, we really should be graphing it, or at least go back to the beginning and take a look and say to yourself, okay, this was cubed, and cubed is that S-shaped snake-like curve that will go something like this. So pretty obviously, if we have three zeros, this one is doing something more like this, or we would not get our three zeros. So most of the time, the best thing to do would be to grab a calculator and take another look at this. So let me go ahead and get the smartboard calculator up here, and we'll go ahead and punch in the y equals, and we need x to the third minus x squared, and then minus 30x. And we know where those zeros are at, so let's just hit zoom 6 so we can see exactly what's going on here. And this one pretty obvious in what it's doing, but let's go ahead and change the window to the y so everybody can see this. It looked like it was going up pretty doggone steep. So maybe we will try negative 10. Let's change that to negative 50. And positive 50. Let's see if that helps us. It's a little better. We're still not getting the local max and the local min here, so maybe go back in the window. And at first thought, I was going to put negative 100, 100 in there. So I will go with that first thought. And hit graph. So here's what we need. We need the x's that will have this graph less than or equal to 0. So we need the x's that will generate this, and the x's that will generate this portion of the graph right here. So this is obviously going to negative infinity right there. And I know where this cutoff is. That was the first 0 that we were talking about. Well, no, not 0. The negative 5, 0. That was the first of the zeros that you come across as you do these in increasing order. And then over here, this is 0 at 0 and 6. And so we can see our interval is going to have to be from negative 1 to negative 5. And because it has the equals bar, we can include the negative 5. And from 0 to 6, and again, it has the equals bar, so we can include those pieces. So we come back to this mess and we say, all right, now that we've had a really good look at it, here's what we know. We know the x's that are going to generate this less than or equal to 0 are negative infinity to negative 5 inclusive, but there's more. So again, we use that u to show a union of the other piece, which is 0, 6. And we have that taken care of. So once we get past a quadratic, and even with quadratics, we should usually make a sketch so that we can see exactly what's going on and make sure that we're able to follow our zeros. Next one that was asked for was number 32. And this one says, we're going to go back to the example that we did in class. Negative 16t squared plus 288t greater than or equal to 1,152. And it says we're going to solve that algebraically, which we did in class, and compare the answer with the result obtained in example 10. So you go through this and you think, well, hey, I can just get this from my notes. I had negative 16t squared plus 288t, and then minus 1152 greater than or equal to 0. We divided the whole thing by negative 16 t squared minus 18t plus 72 less than or equal to 0. And that's because we're dividing by a negative 16. So we have to flip the sign. And then this will be t minus 6, t minus 12 less than or equal to 0. And then we found our zeros. I mean, that wasn't a problem at all. This was 6 and this was 12. But the difference this time is that this is less than or equal to 0. And you'll think, well, isn't that exactly what we did in class? It is, but I did this in class a different way. The way that I did this in class was by moving the t squared and the t over to this side. And again, it gives us the same result here. We're really doing the same thing. We have that closed interval from 6 to 12. Next one on your list is this very nasty constructing a box with no top problem. An open box is formed by cutting squares from the corners of a regular piece of cardboard and folding up the flaps. And for A, we want to know what size corner squares should be cut to yield a box with a volume of 125 cubic inches. Well, volume of a box is length times width times height. So it was 15 inches, but we're going to cut an X out of the top and the bottom. So now that's going to be 15 minus 2X. This was 12. But now we're going to take those two pieces off again, so that's 12 minus 2x. And when we fold this up, the height is going to be x. Now, you can try and factor this one. So we take a look and say, all right, they want this to be 125. So we go ahead and FOIL the 15 minus 2x times 12 minus 2x, and we get 180 minus 30x. Minus 24x plus 4x squared. And then we could combine some like terms. So x times 180 minus 54x plus 4x squared. Go ahead and distribute the x. And then we would find our zeros. So we would subtract 125 from both sides. And it's driving me nuts that these are not in descending order. So I'm going to go ahead and do that right now. And again, we're going to subtract the 125. So you get this far, and you hope beyond all hope that perhaps this is factorable by grouping. And you give it a shot. It doesn't work. In fact, I went as far as putting these two, grouping these two together and trying the other. It doesn't work. This is not factorable by grouping. So in the end, we can go right back up here to the top, and we can plug, actually we can plug this into the calculator as y sub 1 and y sub 2 and just save a whole lot of time. So this would be our y sub 1 portion. This would be y sub 2, and we'll see what those intersections look like. So let's go back to the good old GC. Erase my scribbling. And again, we will make one side x, parentheses, and I better get that deleted out of there before I start in. All right, here we go. So we have x, parentheses, 15 minus 2x, parentheses, parentheses, 12 minus 2x. And then the other one will be 125 because we wanted to see where that intersection is. So I'm just going to hit graph, see if the last window that we had is working for this one as well. And we get that. So it's a matter of, all right, what should we do here? You know, what do we put in? Well, I want to see where those zeros are, exactly where things are at. But I can't see my 125 up at the top, and that's a big problem. So y equals, it froze, there we go. So let's look at 150, because I really do care about, you know, which portions of this graph are going to be above and below that 125. So, two things of interest here. First of all, these points of intersection. Those are going to determine our intervals. So let's go back over here where I can get things labeled a little bit better. And we would use second intersection to find those points. So let's find out where those are at. Second trace, number 5, and there's Blinky down below, but I want Blinky in position to find this first intersection. So enter, enter, enter through guess. And that is approximately 0.942. I'll write that down in a little bit. Second trace, number 5 intersection, get Blinky in position for the second intersection. There's Blinky. And we can see that it's picking up on the 2 that we want. So 3.778, second trace, number 5, and we have one more that we need to get to. And every few hits here, it is freezing. So give me a second here. All right, so that one is 8.788. So let's get those labeled here. This one was our 0.942. The next one was our 3.778. And this one is 8.780. Now, one of those I have to throw out right away. Here's why. My equation started off with 15 minus 2x and 12 minus 2x. And if I put one of these answers in there, it is going to give me a negative volume, which I know I can't have. And that's this 8.780. That is out right away. So I have the other two, and I need to figure out, you know, what do they want here? Well, what size corner squares should be cut to yield a box volume of 125 cubic inches? Well, we would have 15 minus 2x and 12 minus 2x and x. That would give us these answers. That's what we put into the calculator. So 0.942 inches or 3.778 inches. So part A is just, what did you get when you put it in the calculator? What did you see? And then part B says, what size corner squares should be cut to yield a box with a volume more than 125 cubic inches? So this is where we go back to the sketch and we realize that's going to be anything between those two. Now it said more than, it didn't say equal to, so 0.942 and 3.778 would be our cutoffs, but again we can't include those because it said more than. And then C says, what size corner squares should be cut to yield a box with a volume of at most 125 cubic inches? So at most means really we want what's below it and exactly equal to it. So that would be our 0 to 0.942. Now why does it start at 0? Because this is a word problem. And we can't have any of those lengths, widths, or heights be negative. So it's going to start at 0. Union width. And we want to go and start at that 3.778 again. And the reason we don't use the square brackets on those is because we rounded those answers. That's not going to give us exactly 125 because we had to round those answers. So we're just going to do those rounded. And then you say, okay, well, where's the cutoff? I mean, we had a cutoff at 0. We had to stop there. Here's the other cutoff. That's why it was important that we saw everything that was going on with this curve. Notice that that portion of the graph stops being positive at that point. And so that's where we have to stop it, is at the 6. And again, we're not going to include those points. That was it for P7.